Next, let's take a look at the nomenclature. I want to give you a minute to go over this, and if you have any questions, ask. This information will be very useful when you solve the roadmap type of problems. On your exam, you had a problem like that, and I want to bring it to your attention. I told you unknown ether, so you knew right away that in that ether, you do have an oxygen. You had to subtract that oxygen from the molecular mass. So if we're covering aldehydes and ketones, you would be told that you have a carbonyl compound, okay? And if the signatures are given to you, you want to make sure that you understand those signatures and you're using them to distinguish between two isomeric compounds. So if you had an aldehyde, you would be looking for those specific peaks for an aldehyde. And if they're not there, then maybe your two isomers were just two ketones with different R groups around the carbonyl carbon. Okay? So let's move on. Now, we're going to talk about nomenclature. First, let's talk about aldehydes. For your aldehydes, your alkane will simply become an alkanol. Okay, and we're going to talk first about aliphatic aldehydes and then about aromatic ones. We understand that in the aldehyde, the important functional group is the carbonyl. And of course, in your aldehyde, it's always going to be on the terminal position. So we're going to start numbering from the carbonyl carbon. So if we look at this compound, we're going to number it from left to right. 1, 2, 3, 4, 5, 6, 7, 8. The compound is an octanol, but we do have a double bond here. So it will become an octenol. We will need to identify the position of the double bond. So let's do that. Put the parent name in, oct dash. On position number 3, we see the double bond, 3 in, al. Al stands for the carbonyl aldehyde, oct for 8 carbons. Three in for the double bond. And now we can move into the substituents. We have bromine and ethoxy group, 3 bromo, 6 ethoxy. And finally, in the beginning of the name, we need to identify the easy notation and also the absolute configuration on carbon number 6. We can see that our double bond has larger in atomic mass definition substituent on the same side of the double bond, so it's 3Z. And then on position number 6, we have an our absolute configuration, and the name is complete. Okay. So isomerism in aldehydes will not happen in regards to the carbonyl because it will always be on position number 1. But if you have change of position in terms of connectivity on the carbonyl, beyond the carbonyl carbon, it will be your constitutional isomers. And if you have any easy or absolute configuration changes, it will be the stereoisomer. When it comes to the ketones, in ketones, the carbonyl is embedded in the longest carbon chain. Okay. So we're going to recognize the compound based on the carbon chains that carries the carbonyl in. Let's just put a bunch of substituents here. Okay. So again, guys, at this point, there are too many functional groups that are present. So the first thing that we need to recognize is the most important functional group. And indeed, it's our carbonyl. It's a ketone. So alkane will be changed into alkan and on. So N will show the position of the carbonyl. So definitely we're going to start numbering from the left. I wanted to bring this to your attention because many of you did make that mistake on the exam. I'm looking for the longest carbon chain. Many of you started numbering on the exam from this position and use this as a metal substituent. No, this carbon is a part of the longer carbon chain, so we're going to incorporate it in. We have 11 carbons on deck. We have a double bond on position 7. We have triple bond on position number 10. Again, a place where students make mistakes. I want to bring it again to your attention. If I had the alkene, I would put E right here, but I don't have an alkene. If I had alkyne, I would put E here to kind of cap the name, but I don't have the alkyne. I have a ketone, so I'm going to continue. And what do I have on position number 4? I have my carbonyl, so it's going to be on. Okay, so parent name is complete. And then we're going to move on to substituents. I have phenyl substituent and hydroxy substituent, so it's going to be 3-hydroxy, wait, 2-phenyl, and let's put in our geometric and absolute configuration recognitions. On position number 2, we have an S configuration, so 2S. And then on position number 3, we have an R configuration, 3R, and 7E, and done. In ketones, the isomerism comes from the position of your carbonyl. So these two carbonyl compounds are going to be constitutional isomers. Because in one of them, carbonyl is residing on position number 4, and the other one, carbonyl is residing on position number 2. What if you have not just one, but several carbonyls in the compound? Let's take a look at the example where those carbonyls are both ketones, okay? And if your carbonyls are ketone and the aldehyde, what will take priority and so on? So let's take a look at those examples. Okay. Okay, I want to combine a couple of things in one problem so we can cover it with more going into depth. So in this compound, we can see that I have 3 carbonyls. All 3 of them belong to a ketone. However, I have a challenge with it because while I can put 2 of the carbonyls in one chain, or this carbonyls in one chain, or this carbonyls in one chain, in all 3 combinations, one of the carbonyls will fall out of the chain, okay? So how am I going to address that? I'm going to choose the chain that contains the most of the carbonyls and is the longest chain. In this case, we can see that definitely this is my longest chain. So this carbonyl, and let me highlight it, this carbonyl will become just a substituent, okay? So I'm going to start numbering from the side that carries the first carbonyl closer. So again, we're going to start numbering from left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Again, we have undecane as the longest carbon chain. So in my main chain, I will have undec. Remember, if I have 2 of the functional groups, I'm going to retain A in the parent name. Let's just identify that. Dash 2, 8, dione. Di indicates that we have 2 of those functional groups, and it's 2 carbonyls. Now we're going to put substituents in. Very important, please pay attention to that. If I have a carbonyl as a substituent, I'm going to look at the identity of that carbonyl. Over here, it carries carbonyl with 2 carbons in, carbonyl attached directly to the first position, point of attachment, 2 carbons, ethyl becomes ethanoyl. So this group is going to become an ethanoyl. 1 and 2. Let me zoom on it so you can see it better. Okay. And the compound will be named 5-ethanoyl, and then 10-methyl, Andeca 2,8-dione. Of course, I need to give the absolute configuration of that carbon. And let's see what we have there. 1, 2, 3, 1, 2, 3. So we're going to have an S, and we can put it right in front of ethanol because we don't have any other substituents with the absolute configuration, with chiral centers. Now let's take a look at another example here. How would I name this compound? In this compound, again, I do have 3 carbonyls. Aldehydes take priority over ketones. And why is that? Well, because aldehyde carbonyl will always be on position number 1. That's why. So I want to find the chain that contains my aldehyde and is the longest chain. And if I can include in it my carbonyls, would be wonderful. So to me, I'm going to start again from left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. My compound is going to be dodecanal. I have 1 aldehyde in there. Carbonyl in the main chain on position number 4. Because it belongs to the main chain, will be identified by its position and oxo. It does belong to the main chain. Now the other carbonyl is unsubstituent, and it will be identified as alkan oil. Since my carbonyl is residing on position number 1 here, I don't have to really identify its position, but if it resided on position number 2, I would have to put it in parentheses and put 2-propanoyl. Okay, so in this case, when I name this compound, it's going to be dodecanal for the parent, and then I have oxo and propanoyl. So propanoyl is going to come first. It's on position number 7. I believe it's an R configuration, so 7R, propanoyl. Let me move it a bit. And then 4, oxo. the decanol. Okay?
Professor,
Yes.
but doesn't O comes before P?
Are you telling me I don't know my alphabet? Yes, I don't.
So
I don't know my alphabet. Yes. I don't. My apologies. There we go. Thank you, Rita. Was that your question?
yeah, that's what I was wondering.
Okay. Thank you, Rita.
Mrs. O, I have a question. Can you explain really quick the alkanoil and the propanoil, how you determine
Sure.
which to use?
Let me put it on the side. Okay, let's zoom onto that substituent so we will have a little bit more clarity there. Then position number 7. And off of that, I have sorry. I have this substituent. So, Kaylin, when I go over the substituent, position from which your substituent is attached to the main chain is always position number 1. I go towards the carbon chain. It's 3 carbons. It's propyl. Propyl will become propanoil. Okay? Because I have a carbonyl on. And since that carbonyl is residing on position number 1, I'm not identifying its position. I'm not putting 1 propanoil. Now, just to clarify and go a little bit more into detail, if I'm going to put here on the side, what if I had this as a substituent? Okay, so in this case, I have 4 carbons, so I'm going to number that 1, 2, 3, and 4. Okay, and I have my carbonyl on position number 3. So my substituent carries a substituent, and it's going to be, let's say this is position number 7, 8, 9, 10. It's going to be 10, and then in parentheses, 3, I have 4 carbons, and it's going to be butanoil. Some would call it 10,3-oxobutyl, and I've seen it used interchangeably. I'm not the one who assigns the IUPAC nomenclature, so
Professor, for the numbering, the 7 is supposed to be a 6, and then the 10 is, I believe, supposed to be a 9.
1, 2, 1, 2, 3, 4, 5. What do you mean?
In the carbon chain, whenever we're numbering, is it not supposed to be a 6 instead of the 7?
2, 3, 4, 5, 6, 7. Where it should be 6.
The bottom one. The other, not that one. The other.
No, she's just using the other one as an example. I don't think that's the
I'm
real.
just throwing in on the side, I'm concentrating on the substituent, okay? This I just added so you won't think that, well, this is a shorter chain or so on, okay? I'm not looking at this chain at all, okay? All good?
Good, thank you.
You're welcome. Let's just take a quick look at aromatic ketones and aldehydes, and hopefully that will be it. Okay. We already have seen this compound many times. On your exam, you saw it and you called it a metal alcohol because I put it as COH. Guys, you remember that carbon needs to carry 4 bonds, and the only way it will carry 4 bonds here is if it's attached to the carbonyl. This compound is called benzaldehyde. Okay, so carbon number 1, again, a place where students do make mistakes. Carbon number 1 is carbon that carries benzaldehyde, not the carbon of the carbonyl. So if we do have substituents on, we're going to start numbering from the carbon with the aldehyde on and go in the direction towards the first substituent. So the name of this compound, 1, 2, 3, 4. So we have metal substituent, and we also on position number 4 have ethanol substituent. Okay. Or there is a common name that sometimes we use for ethanol. Ethanol is IUPAC, but we can also call it acetal. And this is a common name. So you can interchangeably name this compound as 4-acetyl 3-methyl benzaldehyde. Or you could call it 3-methyl and 4-ethyl. I still don't know my alphabet. 4-ethanol, 3-methyl benzaldehyde. Okay. As for ketones, we already know this ketone, acetophenone. So if you have any substituents on the compound, you're going to go off of acetophenone as the parent compound, put it as position number 1, and go around. Before we leave this page, I want to remind you again the priority belt of the functional groups that we know so far, so you will not be making a mistake. So far, based on what we know as of full coverage of the groups, your aldehyde comes before ketone, comes before alcohols, comes before alkene, alkyne. Okay. And then within the long chain, your substituents will definitely come in alphabetical order. And those will be your alkyl. I'm not putting them in alphabetical order. And then halide, alkoxy, and nitro. We have not covered yet the amines. We will be covering them right after aldehydes and ketones. But if we were to put them there, amines will be coming after your alcohol. Okay, so this is the part of the long chain, depending on which group you have. Everything below is considered a substituent in IUPAC nomenclature. Okay, so we're done with spectroscopic remarks. We're done with the nomenclature. We're going to move on to the reactions, onto synthesis, and let's do that. Let's review old synthesis of ketones and aldehydes, and then we're going to move on to the new synthetic procedures. Formation of the carbonyl is a result of the oxidation, and we've seen the oxidation reactions in Chem 105, starting from chapter, I believe, 8, and then we saw making of carbonyls in chapter 11 and 9 as well. So let's go over them in the order from chapter 8. Oxidative cleavage. Of alkenes. We remember that there is a harsh and mild oxidative cleavage. And since we're looking at aldehydes and ketones, we would prefer to use a mild oxidative cleavage.